Floor is yours. Take it away.
All right. Well, welcome to Chromium C++ 201 Part 4, the last part of this series of talks. Hopefully not the worst part, although some part has to be the worst part, so I don't know. Pick your favorite. As before, we're going to go over several different topics in this talk and then end with a set of assignments. I have occasionally gotten CLs for these assignments, so I know one or two of you read the bullet points, but just in case you don't, this is my plug for make notes of anything that is totally new to you or surprising or at least just dusty and you haven't used it in a while, and pick out your favorite assignment and write a CL for it and help lock that knowledge in. So today we're going to go over localization 101. Which is less C++-ish per se, but I think something that probably everybody working on Chromium should at least have a small amount of knowledge about. Unicode characters and strings, casting, readability heuristics, and then some links to some other C++ guides and things. Mostly those are for those of you who pull up these slides later and want to click through. And once again, in case you wanted to do that, I'll go back to the title slide. The link to this deck is go/chromium-cpp-4. So, and you can find the other past talks at 3, 2, and 1, as you would expect. So with that, localization 101. This is mostly going to be a section about why localization is hard, and not a huge section about exactly how you do it right, because that gets a little too into the weeds of how we specifically use various Chromium APIs and things. I mostly just want to intimidate you and also make you feel like before I do something that comes from users or goes to users, I should probably think carefully about it and consult someone who knows enough. So the first reason localization is hard is simply translation. We have to translate all of our output strings from English into Spanish and all of our other many display languages. We also have to deal with numeric agreement. So in English, you have singular and plural cases. Russian, by contrast, has distinct cases for numbers that end in 1, numbers that end in 2, 3, or 4, and numbers that end in 5, 6, 7, 8, 9, or 0, or anything 10 to 19 inclusive. At least if I pulled the Wikipedia docs on that right, because I don't speak Russian. So for those of you who do, I'm sorry you had to learn all of those, but I guess every language has its own exciting things that it does. The upshot here is that code that just always uses a single string is going to be wrong for both, obviously, but code that tries to fix it by having like a plural version, I've seen people do this in Chromium, is going to be wrong for Russian and various other languages. Case conversion. I don't know if everybody knows about this one, but not all languages convert case the same way. So English simply has uppercase dotless I and lowercase dotted I, and they convert to each other as you can see here. Turkish has both dotted and dotless I. I think they convert across to each other. I'm not actually sure. There may be cases in which one of them converts to the other. I don't know. This is like why you don't just blindly say, well, I'm going to normalize all my strings by running 2 lower on them, and then I can do like case insensitive matching and it'll work correctly. Any kind of case conversion algorithm that just blindly normalizes one to the other in the same way is going to be wrong for either English or Turkish. So it has to take the current locale into consideration. Number formatting. Holy cow, half the world can't agree with the other half the world on what commas and periods mean in numbers. I don't really care, pick one like endianness, but we didn't. So unfortunately, if you're parsing floating point strings from users or you are displaying things, then you're just going to have a bad time. Whitespace. Breaking words on Whitespace is something many languages do. Not all languages do it. So Thai, for example, doesn't necessarily put white space between its words, although I think in some cases Thai does put white space between its words. So I don't know. Again, like, point of all this being, I am not a localization expert. I am just as confused by some of this stuff as you are. But once you know where the potholes are, sometimes you know when to be cautious. So code that blindly concatenates strings with space dash space. I've seen this done. Because, like, clearly spaces between words are a thing, and dashes are like a way to indicate a relationship between things. This is not localization friendly. Don't do this. I believe we used to do this in the Omnibox code. I hope that's been fixed. I don't know where else we might do stuff like this. Right to left. Holy cow. Lots and lots and lots of problems here. Here are some of the questions that I have personally run into related to right to left stuff. Which way should play button arrows point on media controls? And also, which way should next and previous track buttons point? And which side of the play button should they be drawn on? I have no idea. Should folder icons for bookmark folders or file folders be drawn mirrored when you're in an RTL context? What do we do when we're displaying a URL like the ones on the screen that has both right to left and left to right content in it, especially if, unlike the ones on the screen, it's in, say, the path component of the URL. So it's not even clear like what order you're looking at the various different components in. Once again, all real questions I've run into, usually the answer is you consult one of the internationalization folks on the team, and then they argue, because even though they're, for example, multiple native speakers of Hebrew, they still don't agree on how a Hebrew-speaking person would expect to see something. But at least it's them arguing and not you. Oops, skip the slide. So if you want to do all these things right, you probably are going to want to use International Components for Unicode, or ICU, as it's much more readably called. ICU is a third-party library that we use. It's an official subgroup of the Unicode consortium that puts it together, so it's in theory authoritative. In practice, I mean, they have bugs and feature requests and whatever, just like every other project does. So not perfect, but there are Google people involved in the process, so you can get a line onto the committee if you need to. It takes care of all kinds of things for you, like a lot of the ones that I've showed so far, plus other things. Time zones, that's a fun one. How do you know? And they're changing year by year, so you don't want to maintain your own list. In the chat, people are noting various things about all these different examples, such as that for icons, we should just show them the way that we do in LTR context, which it sounds like a perfectly reasonable answer to me. But any answer would have probably sounded like a reasonable answer to me. So the upshot is I personally don't have an instinct, unfortunately. And then Chromium does some wrapper-specific bits, or some specific wrapper bits around ICU and various other things. The one you'll probably interact the most with is the utilities in L10n util. These are things like getStringF. If you want to fetch a translated string in an appropriate language and often formatted for plurals correctly and insert substrings into it in the right places and munge it the right way, you're looking at things in L10n util. Those specific strings live in what are called GRD files. I'm sure GRD is something saying like Google Resource Descriptor, or I don't know what that means, but they live there. And then XTB files are the translated strings that come back from our translators. So hopefully you won't be dealing with these directly, but you will be getting resources out of them via the L10n util functions. Anyway, again, not a lot of guide on how to use all this stuff correctly, just a very whirlwind tour of it exists, these things are real, like Chrome has to deal with them. So in case you touch stuff, there you go. So questions on very brief intro to localization 101. All right, let's move on to Unicode characters and strings. So closely related topic. I'm going to talk about character encodings here. And character encoding is a kind of a loaded and multi-meaning term. So I'm going to introduce some more specific vocabulary to talk about it. Oh, that's awesome. Like on this Mac, apparently it doesn't do the musical clef symbol that I had in that repertoire thing. So apparently, like, don't present from no, this isn't a Mac, this is a Chromebook. All right, whatever, it's our product, we fail. On some OSs, like the one I composed this on, there's a treble clef, a musical G clef symbol on that repertoire thing. And repertoire is basically just the set of characters and other meanings, like form feed or something like that, that you can encode. So the Unicode consortium continually adds to things here. You have like characters from all different languages and scripts. There's a bunch of languages that don't have characters represented yet, and people are working on adding those. There's, you know, various graphical symbols and emoji and things, and people add those. So the repertoire is continually getting bigger in Unicode. Then you have some set of mappings that give every one of those characters a number, and those numbers are your code points. So in Unicode, the code point for the musical clef that you can't see is U plus 1D11E. It's in hex. You can see that that takes more than 16 bits of hex. There's more than 65,000 characters in the Unicode repertoire. Then you break that down. Your code points may be bigger than you want to deal with in the particular containers you're holding them in. So you break them into code units. So UTF-16, for example, uses 16-bit units, and it breaks that 1D11E into the 2 units that I've displayed here. Their exact values aren't very important, just that there is a mapping. And then finally, below units, you generally always have to have some kind of way to disassemble into octets and then reassemble for transport over a network or storage on a byte-based file system. So UTF-16 Big Endian just says read off the bytes from the Unicode code units in Big Endian ordering. So there's some vocabulary for you. When people talk about character encoding, they may mean any or all of these things. And the simplest character encoding that we use in Chromium is ASCII. ASCII, which bonus points if you can remember off the top of your head exactly what that stands for. I think I can, but I'm not sure, and I'm not going to guess right now, is a system where all characters take 7 bits. So you have 128 characters, and then often people will encode some other set of things in the upper 128 characters of the byte. So there will frequently be another 128 bits, but those aren't specifically part of ASCII. The Unicode code points include all of ASCII at the same values. So if you have a string that is ASCII, it is also Unicode. It's UTF-8, etc., UTF-16, whatever. And if you need to know off the top of nothing what the values of some things in ASCII are, you can go to this handy website. I use this probably once every couple of weeks or so, ASCIItable.com. So this is a very useful site that just says, hey, what's the hex code for capital letter A or something, just in case you don't have that burned into your brain like I don't. Another common encoding in Chromium, UTF-8. So UTF-8 is an encoding that uses 8-bit code units. That means that the code unit to octet conversion is just 1-to-1. But the code point to code unit conversion is kind of interesting. It's a variable length encoding setup. So characters commonly fit in 1 or 2 units, but they might require up to 4. And each byte tells you whether you have another byte following that's part of the same character. UTF-16 encodes all the same values, same repertoire, same code points as UTF-8, but the individual code units are 16-bit, not 8. So characters typically fit in 1 unit but may require 2 units. Wow, there's a UTF-EBCDIC. Wow, that's a disturbing fact. I did not know that. Random things from the chat. And then there's a variety of uncommon encodings in Chromium. I'm not going to go over them because they're uncommon and we don't want to take forever in this talk, but things like Big 5 and Shift GIS and other exciting encodings, the old Windows code pages. So how do you deal with these UTF-8, 16, ASCII, et cetera, types? What do you store them in? How do you declare them, et cetera? Well, common character and string types in Chromium include the standard good old char type and std string, which you declare. Hopefully, if you know enough to be in a C++ 201 class, you know how you declare a character or a string, but with single quotes or double quotes, respectively. These can be used to store anything that's 8-bit, so they can be ASCII, they can be UTF-8, they can be random stream of bytes that does not encode characters, they can be you don't know. C++20 actually introduces a U8 string type that is explicitly UTF-8 strings. Unfortunately, since it's a different type than std string, you don't get to just sort of like reinterpret cast between one and the other. You have to do type conversion and be consistent. And since like every API in the universe uses std string or char star or something like that, Chrome doesn't use it and probably will never use it. Also, it's C++20, so we can't use it yet. But even when we can use it, we probably won't. There's char 16t and U16 string. If you're looking for string 16, it doesn't exist. We removed it earlier this year in favor of U16 string. So in case you didn't notice that change, go through the code base. That happened. And this means that you can declare 16-bit code unit literals with a leading U and then quotes. So if you do U quote stir, it means give me back a U16 string that has this string in it. WChar-T and std-W string. So these are obviously declared with L because L stands for wide. And you use these primarily on Windows. The reason you don't use these on other platforms is basically because on Windows, wide strings are 16-bit, and on other platforms, wide strings are 32-bit. And the reason for that is confusing, but what that means is that on other platforms, they tend to use very large values for each character, so it wastes a lot of memory. It costs performance to iterate over and do things. So we generally just use wide strings on Windows where you have to use them to interact with a lot of the OS APIs. And we almost totally don't use it elsewhere. There are a few places, but not much. So given all of this, let's say I want to put, I don't know, a smiley face into my code. How do I put a smiley face in my code? Well, the easiest way is to put the smiley face in your code. Just paste it in, the actual like Unicode character literal. And this is because our source files are not ASCII, our source files are UTF-8. So they can encode Unicode characters. And Unicode generally is allowed in various string constants, sometimes even in identifiers. Please do not do that. Like, don't make your C variable identifiers have like emojis in them or something. Like, just don't. But you can put, say, a quoted string that contains a smiley face. If you don't want to do that, say, for example, because somebody needs to know that that smiley face is U plus 263A, then you can use the escaped form, which is \U. Lowercase u for something that fits in 16 bits, and then they added capital U for something that takes 32 bits to represent. So these ends are hex, and you just do /u 263A or whatever. What you should not do if you're encoding characters is you should not use /x, which is give me a hex byte. and then do something like this, which is the UTF-8 expansion of that particular code point. So the reason you should not do this is, for one, because it's extremely non-obvious that /xe2 blah, 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 blah means smiley face. I mean, much easier to read a smiley face. And even easier still to read that U263A, like that looks like a Unicode code point that I can look up. This doesn't look like something I can go Google for. But also because when you put this sequence inside some kind of quoted literal, and then later on we change it from a UTF-8 string to a UTF-16 string, your bytes are just going to be expanded to 16-bit values that hold that byte. And now it's not going to mean anything. So don't do this. The only reason you do need to do this sometimes is you do need to do this for any string that contains like a non-legal character literal in Unicode. Like, for example, I can't remember the name of them, but the various different characters that are explicitly not allowed in encodings. Alice says, I have a hand up. Yes? No? Oh, by mistake. Okay. So if you need to encode something that's not a character or it's not legal Unicode, then you might have to use /x. Unpaired surrogates. Thank you, Derek. That's what I was trying to think of. So that's the only reason to do this. If you need to convert encodings at runtime, then we have handy functions to do that. And the most common pair that you will encounter are base UTF-8 to UTF-16 and vice versa. And these, you use them exactly like you'd expect to use them. You pass in one, the other thing comes back. You can also do ASCII to UTF-16 and UTF-16 to ASCII, but this is generally a mistake because you're in one of two scenarios. Either you have the ASCII string and like you know it's ASCII because you wrote it, like it's a compile time constant. But then in that case, why didn't you just declare it as a UTF-16 literal to begin with? Or the other case is you don't know that this is ASCII because, say, it's coming over the wire to you or something like that. And you probably should be using UTF-8 to UTF-16, or you should be checking whether each character is ASCII before doing this, which is like slow and ugly, and don't do that. So this is usually not the right thing to use. We finally have wide UTF-8 and 16 and those conversion functions. Just like with WString, hopefully you won't need to use this unless you're wearing Windows code, in which case, yeah, you probably will need to use this. And then also, you may have run into these cryptic looking things scattered about the code base sometimes. These as WCster, as U16Cster, blah, blah, blah. These are conversion functions which basically quickly convert between wide and UTF-16 by casting, which is not legal on Windows and definitely not going to work on any other platforms. But we do it anyway, and we violate the strict aliasing rules. Ellie, you had a hand up.
Yeah, I think it's worth pointing out that a lot of these functions can fail at runtime.
Yes, for example, if you pass something that contains one of those unpaired surrogates to UTF-8 to UTF-16, it's not going to convert it to valid UTF-16 for you.
And in fact, the conversion functions that are the most ergonomic to use will partly convert the string and then return like their best guess as to what you meant. They do not actually have the failure semantics you might expect.
So in general, if you're getting user-defined input from somewhere, you probably should be paranoid and assume that it's hostile and filled with all kinds of encoding errors and things that are designed to trip your algorithms up, just like good security practice elsewhere. So with these WCster, U16Cster, et cetera things, basically, because Windows uses wide strings everywhere, and because the rest of Chrome uses U16 strings everywhere, and because on Windows those two things are the same encodings contained in the same widths, we reinterpret cast them. And this violates C aliasing rules. But we do it anyway. And at least we have contained it in these functions so we could go and fix it up to do it in a standards compliant way someday. and measure the perf impact. If you don't know what strict aliasing rules are or why this violates this or something, that's totally okay. Doesn't matter at all, and just ignore that I said all that stuff. Alice, you got a question?
Yes, I finally actually have a question. Is there any runtime check for whether these conversions are legit? Like, let's say we were squeezing 16 into 8 and then it's not squeezable, and it will result in a weird string or garbage string. Is there any runtime check for that, or we just like pray and hope that
So this is a question applicable to conversion
all of
functions
them, yes.
like these.
Yes.
So yeah, on things like when you're converting 16 to 8 or whatever, the nice thing is that since UTF-16 and UTF-8 both encode the exact same set of code points, there's no case where valid, like one of them doesn't convert to the other. Like squishing 16 down to 8 is a matter of taking what the 16 was encoding and encoding it differently in 8-bit code units. So they may take several 8-bit code units. In fact, you may end up with a longer string than you had in UTF-16 in rare cases. But it's always going to work if you have valid input coming in.
Oh, I didn't know about that part. I thought it would have a smaller set of characters. Thanks.
Yeah, UTF-8 and UTF-16 are both encodings for the full Unicode repertoire. So
okay,
you're
sounds good.
there.
Thanks.
So Caleb asks, what about bitcast? Doesn't bitcast avoid the aliasing issues? And that is a good segue to our next section, which is casting. So in casting, I don't know if I actually still have a slide in here on bitcast, but we'll see. I might. So hold that thought. Types of casts. The most common cast that you're going to encounter in C++ is the static cast. And static cast is kind of the compiler knows how to make a change between this one thing and this other thing, but you might have to tell it to do it explicitly because maybe it won't do it for you automatically, or maybe you just want to tell it to do it for clarity for the reader. So, please static cast my double to a float, for example. Yeah, Alice. It says you've raised a hand. Okay, now you have not raised a hand. So static cast, probably the cast that you'll run into all the time. Const cast, if you run into this, hopefully it is in the context of this horrible looking idiom that I have actually had on a previous slide. This is the idiom for doing define my non-const member function in terms of my const member function, which is gruesomely ugly, but is a thing if you need to write both const and non-const versions of the same member function, and they basically do the same thing. And your const version is like really big and long and ugly, and you don't want to copy and paste it. So this is that idiom. I think this came up in part 3. Don't remember which part, but one of the parts I've mentioned this already. So const cast is a cast that can be used to remove const from an object. Here we're using it to remove the const off the const t star that we would have gotten back in this idiom case. If you are seeing const cast a lot, or you're seeing const cast to do something like add const, that's very strange. Const cast is not necessary to do that. Then you're probably seeing buggy use of it. We do have places in our code base where we, in the past, have forbidden const. For example, the content API didn't used to allow const anywhere. It now allows const on member functions that content implements. So, oh dear, no, actually don't do what Ellie just said.
Oh, really? I'm intrigued.
Sorry, not to say that you're horrible or anything like that, but if you write this is an aside, but Ellie suggested in chat, if you write the const version in terms of the non-const method, then you have a lot less casting. You don't have a scary const cast. The problem with that is that now you have a const method that is under the hood calling non-const code, and the non-const code can do anything, including be non-const, and actually like munge your internal member state. So this allows you to very easily have a const method that changes the visible state of your object, which is exactly not what you want in a const method. Or if not now, then in the future, somebody could add that and the compiler would not catch you doing it. Yeah, the recommendation is actually implement your non-const method in terms of your const method because you know that's safe. Your non-const method is allowed to do more. Moving on from const cast, we have reinterpret cast. Reinterpret cast, I'm going to try to scare you and basically say that every case you run into it is wrong. That's not technically true. There are legitimate uses of reinterpret cast. But if you use reinterpret cast to cast, for example, within a hierarchy, like you're casting a derived pointer to a base pointer, you may not have known this, but those pointers' values are not actually the same under the hood. It's not just a reinterpretation of the exact same number. The compiler may have to do some kind of change to fix up the pointer when you do a static cast there. Static cast does that fix up. Reinterpret cast does not do that fix up. If you get this wrong and you use reinterpret cast, you will have very unusual and cryptic errors because you have a pointer that's pointing into like part of an object, but that the compiler thinks is pointing to a different part of the object. And boy, is that fun to track down. Ask me how I know, several times. Also, if you do things like this second example here is what we call type punning, which is where we take some type and then we pretended that it's actually a different type. And we say, well, I understand how IEEE 754, I think 754 is the floating point standard, is represented. And so I'm just going to say that this integral value is actually a float and tell the compiler to do that. This is undefined behavior. Don't do this. What's the correct cast for parent to derived? Static cast is the cast that you want for parent to derived. Let's see. So there is one case where the style guide recommends using reinterpret cast, and that is where you're casting from void star. Technically, this could be a static cast, but the guide recommends using reinterpret cast precisely because it's very scary and you want to terrify readers of your code, which I guess is a valid reason to use reinterpret cast. But other than that, if you run into reinterpret cast, be afraid, be very afraid. The code is probably doing something illegal. Dynamic cast, you won't see this in Chrome. This is a way to do a cast like within an inheritance hierarchy at runtime and then check whether the result is valid or not. So if you have something like, say, a derived pointer here that you're trying to say, like, was my base pointer really a derived pointer or not? You do a dynamic cast and then check whether it's null. The reason you won't see this in Chrome is because you need RTTI to use it, runtime type information, and Chrome doesn't compile RTTI into the binary. So dynamic cast just won't work. We do have some dynamic cast looking things later, so I will get to those, but dynamic cast is something that you just can't write if you're used to it coming in from another project. Ian asks, what's the correct cast for bytes off the wire into a float? And I would say the correct cast is probably bitcast for that. Hopefully I do have, since bitcast has come up twice, I'm hoping I have the bitcast slide in here. Yes, Alice.
So what if I have a parent class pointer that's returned by a function where the underlying object is actually a derived type, but we return it to an std unique pointer because we want it to be passed everywhere and for the derived class and whatever. And then let's say in the places where we actually use the parent pointer, let's say it's a unit test or whatnot, we do want to check whether it's the correct derived type.
Yeah, so I will get to this some in my future dynamic like cast slides.
Okay.
But briefly, there are various ways to check whether things are the right type. And the style guide suggests not doing this as a general practice. It usually is a code smell if you're kind of like taking your pointer and saying, am I a such and such, and then do things based on the result of that.
Well, let's say we're not doing different things on the result of that, but it would only be an operation to do the following step if it was the correct type. Would we still use static cast?
Sorry, can you repeat the last part of that question? I was
So
distracted.
let's say we were not going to have different behavior if it was different types, but the following steps might only make legit sense if it was a particular derived type.
Right.
Do we still use static cast?
So you want like a D check or something like that.
Okay. Okay.
Yeah, like in general, knowing whether something is actually the type you expect either requires RTTI or it requires you to do something RTTI-ish like that. So you have to annotate the type yourself with some kind of type information or other information that lets you know.
Okay.
Because static cast will just, it'll either compile or it won't. And if it compiles, it will just cast.
But would it fail to cast if they are not actually a parent-child relationship?
No, in that case, it won't compile.
It won't compile, okay.
If you try to cast, for example, a derived from class A star into a base B star, then that just isn't going to compile. The compiler will say, like, I don't know how to do this conversion. I'm sorry.
Okay, sounds good.
Reinterpret cast will say, okay, and it will do it. And then you will get who knows what the heck behavior.
Yes, that's scary.
Types of casts. Bonus points, by the way, if during this interim you've been looking at that code on the screen and saying, hey, I know what that code is. That's one of the many Easter eggs in this particular talk. This is the C-style cast, cast with a type in parentheses. And basically, you shouldn't use this because it means a combination of the previous C++ casts that you should just do as the C++ casts. So, use static cast, use reinterpret cast if you have to, but don't use C-style cast because it could mean anything. Ellie.
What happens if you use dynamic cast with no RTTI? Because I was astonished to find that we do use dynamic cast.
Yeah, I don't know. I was looking at your chat thing, and that, in fact, is part of what distracted me in the middle of Alice's question, because I was like, whoa, that's really, like, kind of scary that we use dynamic cast. I don't know what happens either. Probably bad things. As you said, these can't be right, unquote. So yeah, that's my thought as well. Then finally we have this thing. This is not technically a cast, but we use it kind of like a cast in a few places. Basically, this is a way to initialize an unnamed temporary of some type. And it pretty much can be used to perform a subset of what static cast does. So doing your type name within curly braces is the preferred way of doing arithmetic conversions if the compiler will let you do it this way. So widening conversions, for example, where you need to force it to widen to a specific type, do it this way rather than using static cast. For one, just because it's more readable. Like, type name with curly braces is a lot better than static cast, blah. Yeah. But for another, because it's more limited, and so the compiler will catch you if you try to do things like throw away information in a narrowing conversion with this cast. The compiler did not used to catch you in that case. I fixed that earlier this year, so that should be working correctly now. Now, hooray, Bitcast. So this has come up a couple times so far. People have been mentioning it. So we also have some other casts in our code base that are not technically casts, but they work like casts. Base bitcast is one of these. Basically, bitcast is the way to do type punning, and it's the way to do it safely. I think under the hood, what it does is it actually like allocates space for an object of the correct destination type, and then it mem copies into that location. And because you've allocated by the correct type, it's legal for the compiler to then look at the bits in that location as that type. So then you're allowed to do mem copy into it, and you get kind of what you want. The code here is an example that's slightly modified from someplace real in our code base. I don't actually know why code in our code base needed to do this, but this is some floating point like mantissa and sign bit and whatever munging that they're doing here. If this scares you, that's probably a good thing, because generally code that does this is very special purpose. Base saturated cast and its close friend clamp. Clamp round, clamp floor, clamp seal. There's lots of code that does something like I is std round of f. Well, this doesn't do what you wanted it to do for two reasons. For one, std round returns a floating point value still. For another, what happens if the floating point value that you got back is actually too big for the largest integer? I don't know, but you probably don't want to find out. What you probably want is you probably want saturating behavior, where like anything that's outside the range of an integer gets clamped to the largest integer and so forth. So you probably wanted something like clamp round or saturated cast. And these are basically just saturating casts that do exactly what they said on the tin. If you want to be even more strict than that, we have base strict cast. And strict cast says, put it in the target type or check fail and die. This is useful for security sensitive code where you're like, this must fit in a 16-bit value because I expect to have that here. So strict cast is exciting. And then finally, we have a couple of different sets of functions that are used to do dynamic cast-like things. So some examples of doing a dynamic cast to check whether the thing is the type that you want are views is view class and blink has is at least on like the element hierarchy. So you use them, you know, if is view class blah, you know, t my class of view, and it says like, you know, true or false, this is in fact your class type. So this is basically what Alice was looking for earlier. The reason why these work and RTTI and dynamic cast don't is because effectively they emulate RTTI like manually. They annotate the types under the hood. But because they're opting in particular types to doing it, it's much less code impact than just doing RTTI across our whole code base, which costs megabytes. So it's more preferable. Similarly, you can do blink 2 and dynamic 2, which is basically like your actual true dynamic cast of go try to convert it to this type and then either decheck that it's the right type or do a conditional or something like that. All of these, as I said before, violate the style guide's prohibition on doing things like this. So if you want to do something like this and you are a fan of design patterns, which I am not, but some of you are, you should go check out the visitor pattern. The visitor pattern is also known sometimes as double dispatch. Or you could just use virtual methods in some cases, which are single dispatch. I'm not going to explain those at all because that's 301 level stuff, but there's some fun asides for you to go get nerd sniped by. So, questions on casting. Sorry, I know that section was really long, and I apologize. All right, let's move on to the most exciting part, the part where Peter opines. Readability heuristics. So this is where I'm going to say everything in these talks is my opinion, but this part is especially my opinion. This is not Google style. This is not Chromium style. This is Peter Kasting says that he likes X. You should take it with salt appropriate to a statement like that. There are other people on the team, including people in this talk, who have opinions that differ from mine. And they also have valuable points to make. So I would love to see other talks where people go into their readability heuristic ideas. But these are mine for purposes of discussion. I think that code is most readable when you write code like you write natural language. And when you write natural language, you do a lot of different things that I'm going to go over on the subsequent slides. For one, you talk more about what and not how. You say, Peter made a peanut butter and jelly sandwich. You generally do not say, Peter went to the drawer and got out 2 slices of bread. Then he got out a knife and some peanut butter, and give the whole step-by-step explanation of what I did. Yes, I can back figure that I made a peanut butter and jelly sandwich from that description. But that's probably not what you want to tell me. You want to just tell me I made the sandwich and move on. So I had a point in, I think it was part 3, not sure, where I went over some of the different algorithms and basically said you can use these to minimize raw loops. Minimizing raw loops is really one way of minimizing talking about the how and instead prioritizing talking about the what. When I read the first one in English form, I read it as something like, I goes from 0 to the biggest thing in vec, and x adds up every element that I points to. Okay, x is summing the things in vec. And then when I read the second one as English, I say x is accumulating vec. Oh, and that's a lot shorter. Now, admittedly, if you're not familiar with the accumulate function, you may not know what each of these individual arguments does. And it may take you longer to read the second than to read the first because you have much more practice reading the first. I'm simply arguing that putting the accumulate bit right up front lets me scan through and say, you're accumulating, and move on mentally because I don't really care what the rest of the arguments are. Use pronouns and use analogies. We do not say, Peter drove the car to Peter's office so Peter could talk to Peter's friends. Like, we say, like, so he could talk to his friends and things like that. Pronouns have antecedents that they refer back to. Similarly, it's a good idea to use things like auto to eliminate duplication of types, or to use overloading to make an analogy that to a similar behavior that you understand. I'm a big fan of eliding text by using these kinds of methods and not using like dot equals blah, blah, blah. The Google Style Guide has been moving slowly in this direction over time. It's not quite as gung-ho on things like auto as I would, but it does go there. Perhaps the suggestion I have that is most controversial, use comments when you want to call people's attention. So direct readers focus. A comment is a big flashing sign that says, hey, look here. That's precisely the wrong thing to do on something like a functions argument, because most of the time you don't actually want people to look here at the functions argument. You were merely trying to explain it for somebody who really wanted to know, like, what does true mean here? Well, there are other ways of doing that, and all those other ways are better. Even if it takes more lines, like writing a comment that says why you're doing something instead of how is at least a better way of having a flashing sign that does something important with people's opinions. But in general, I would rather you just say frobulate true than frobulate aggressive equals true, like this comment thing does. There are other people who disagree with me violently on that one. I'm going to stick to it and say I think this code is strictly less readable. Go use an IDE, use code search tools, etc. if you want to know what that particular variable is. So use comments when you want to call people's attention. If that's not clear, use enums, use variables, etc. Somebody gave me the great analogy once that comments should be like the bold text in a testing on the toilet episode, in that I should be able to read just the comments and get like exactly what is going on and no more and no less. And if you have more comments than that, you have too many. And if you have fewer comments than that, you don't have enough. I don't know whether that's a perfect heuristic, but that seems like an interesting one to me to try out. Don't repeat yourself. Don't repeat yourself. So at the macro level, you can do this by using helper functions, scoping objects. Scoping objects are great for avoiding repeated cleanup work. I talked about scoping objects in a previous C++ 201 talk. Helper functions, if you do the same code more than once, factor it. into a helper function. Like 2 times is enough to factor it out, in my opinion. At the micro level, you can use temps to hold the results of repeated subexpressions. You can use question colon. So question colon grammatically is not the same thing as a conditional. And by grammatically, I mean both in the sense of C++ grammar and also in my analogy to English. So in English, I would say we have a difference between when you have distinct verb clauses like Bill talked to Alice and kicked the ball to Fred. Like those are distinct verb clauses. Bill is doing 2 different things. Versus when you just have distinct objects. Bill talked to Alice and Fred. Like that's just 2 objects. So question colon is for when you have the same verb, so to speak, and you have 2 objects. Conditionals are when you have 2 different verbs. The example I have here is just modifying the value of X position. And it's doing it by a different value. So it's using a different object, but it's doing the same action, which means that grammatically, to me, this is a question colon. Not because you can write it as a question colon, but because that actually better expresses the intent of the code in red. The code in green is a more accurate way of saying, like, what am I trying to do here? I don't know. That's an extremely like fluffy, hand wavy opinion, but finally, and this goes along with don't repeat yourself, brevity is the soul of wit. So all other things being equal, and no, they're not always sometimes equal, minimize total lines of code. If you have fewer lines of code, then I have fewer lines to scan over, and it's easier for my brain to put together big picture stuff. And big picture outweighs small picture every time. So like forest, not trees. Even if the individual line is slightly more cryptic, I would still optimize for like the 1 line. Not everybody would, but I would. Footnotes are distracting. So if I have to read some code anyway to understand what you're doing, then prefer to inline it. Like the code in question here, this is kind of hard to show in an example that takes very few lines. But if I have some constructor of awesome view and it takes several different arguments, and all it does is create header and create body. I mean, on the one hand, that's really great and very readable because like now I know that awesome view creates a header and a body, but probably those are like significant enough and I need to know what it's doing with the variables or something, and they're only called once, that maybe I should just inline it. And especially I should consider inlining it if I'm passing types back and forth between the functions. Because then, like, every time I change the type of A to, like, double A or something, I have to go change multiple places. Because I have to change awesome views constructor and I have to change create header. You know, and then if it's passing something back to me, then I have to change that and that, etc. I mean, all of these are rules of thumb. So obviously, if create header, as Rachel Bloom is asking in the comments, if create header and create body are each 400 lines, do not inline them because they're not footnotes. You are not David Foster Wallace. Do not write a whole book that is footnotes. Like, if it's a footnote, if it's like, you know, 3 lines or something, then inline it. If it's 400, no. Ellie.
What do you think about this pattern, a variant of it I've seen where create header and create body are both lambdas that are defined inline in this function, and then the bottom is just like create header, create body?
I would say for me, this falls under minimize total lines of code. And if you can write it in significantly fewer lines of code without doing that, I probably would do that. And I probably would simply give the 2 blocks like comments, a block comment, and like separate them with whitespace and say that that's good enough. And if they're so complicated that like a single block comment and separation with whitespace is not good enough, then probably they should be neither lambdas nor inline. They really should be out of line because at that point, again, they're not footnotes. They're functional.
Gotcha. Okay. I like the lambda approach because it avoids the type binding you were talking about at the interface because you can capture the variables by reference instead.
I would say in that case, like the lambda is superior in that way, yes. Samuel.
How about unit tests? Do you do things differently, or you can make it more repetitive for modification and understanding and such?
My personal philosophy is unit test code should be written exactly like production code. Not everybody's philosophy is that way. And I will admit, I don't care as much on unit test code. If you want to come to me with a code review and you're like, I am committed to doing it this way, I'm like, okay, fine, +1. I will let you land it probably in cases where maybe I wouldn't in production. Ellie.
Yeah, I want to echo that because I gave this earlier talk called Design for Testability, where I said that if your unit tests are repetitive, it's usually a sign that your API sucks. Like your API is too low level or requires too much setup to actually use. So if you find yourself copy pasting a unit test, that is a valuable signal that you should change your design. So I think unit tests should read exactly like production code, and I push back in code reviews if I see like unit tests that are really long or that like are factored poorly or whatever. I push back pretty hard.
Yeah, Gab also echoes this in the comments. So great. I have nothing to say. I think that's amazingly good advice. Let me move on to the last couple slides of the talk since we're just about out of time here. Other guides and tips, I don't expect you to like go, click on these virtually by touching your screen. Actually, if you could do that and navigate it, that'd be like really cool through my presentation. But simply, there are some links in my slides to other guides and tips, the C++ style guides of various types. The Chromium Chronicle, that's basically the Chromium testing on the toilet thing, the Chrome on the throne thing. Absol's tip of the week also has useful C++ and Absol-specific tips. I don't always agree with them, as sometimes they're probably right and I'm wrong. And finally, a tip that's so handy it needed its own slide right at the end, because this is like one of those, like, if I'm going to leave them with anything, I'm going to leave them with this. Godbolt.org. If you don't know this already, just go to this website, because man, I use this on like a daily basis. It is so helpful to have a little compiler in a web page that you can put random snippets of code in and test to see whether things work and what error messages you get, and what the output of such and such is, and hey, what if I tried compiling it under GCC, and all of that stuff. Great things. Godbolt.org does all of that for you. So finally, assignments, I'll just put them up on the screen because there's way too many for me to go over, and you can feel free to scan through these and write down one. But that is it. So I think we have 1 minute. Any final questions or thoughts on life, the universe, and everything?
I have a thought, which is that I have learned a whole lot from this series of talks, because I would have already called myself an experienced C++ developer before these talks. So thank you very much for doing all of these.
You are very welcome. And feel free to send me ideas for other talks or series that I should do, because I love giving talks, but I don't know what I should give a talk on next. So. Okay, well, with that, I would say we're done. Thanks very much for your attention.
Thanks, everybody. The recording will be available probably later today.